Here's polynomials intro. Last year we talked about quadratics. Do you remember quadratic functions? And we also did linear. Do you remember inequalities when we had to draw straight lines and then shade certain? So we did linear as well. So basically you have degree of 1 is linear, right? Which looks like this in general. Y is equal to ax plus b. I know you're going to say, Mr. Dirksen, wasn't it mx plus b? Wasn't that mx plus b? Slope is a grade 10 concept you learn, but once we do polynomials, like various degrees, we always put an a in front of the variable with the highest power. So we just call that the leading coefficient, okay? Degree of 2 is a quadratic, and in general, it looks like this. Ax squared plus bx plus c. Degree of 3 is a cubic. That's new for most of you. It's a cubic function, and it looks like this in general. Ax to the power of 3 plus bx squared plus cx plus d. And if it lined up like it did for me, it lined up pretty good. The a's are all kind of lined up. If it didn't, it's not a big deal. But these ones here are called the leading coefficient. Leading coefficient. It tells us a lot about the function. It tells us which way it's going to be pointing. Okay. And for every single one of them, there's a constant at the end. There's a constant. And those collectively, I'm just going to make an arrow to every single one of those last letters. Notice that every single letter doesn't have a variable attached to it, right? None of them has an x at the end. It's always just a letter, which means that's going to be a number. And that number could be 0 as well. If it's not there, then it's 0. But that's what we call the constant. Okay? And that's going to give us the y-intercept. That's going to give us the y-intercept. What is the y-intercept? It's where the line crosses the y-axis. That's what the y-intercept is. So it's going to actually give us the coordinates of the y-intercept. Okay. So, and maybe just somewhere beside the linear, I'm just going to say, if you were to graph them, you would have a straight line, either going up or down. Okay. So you could go like this, or it could, whoa, what happened there? Into the abyss, and this, right? So you've got linear functions going this way or that way. You have the booklet, right? Degree of 2, what does that look like? Anybody remember the name of it? Starts with a P. Up. Parabola. Okay? And a degree of 3, that's new. I'll give you, there's two different variations of a cubic. It could go like this. It basically makes just a little turn like that. Or it could actually bend twice. So watch this, it goes, there's a bend like this, goes back up, and then it bends down again. So that's kind of like your cubic function. And obviously it varies, it will vary, but those are your 3 polynomial functions. We're going to kind of cover. Oh, thank you. I can grab it from here. Thank you.
Yes, you're welcome.
All right, so busy today. So that's just a reminder. For some of you that have not taken applied before, the calculator part is going to be new to you. So if you need extra help, you might have to like see me at lunch for a lunch or two. I'll just catch you up on some of the functions of the calculator, okay? Let's keep going. So this is a little bit of the theory behind everything. Okay, so page 3, polynomial functions. Polynomial functions contains only the operators of multiplication, addition, and subtraction. Has real numbers with the coefficient, right? So x and y would be part of the real numbers. Has whole number exponents. They have a degree. They have degrees. That's how smart they are. Okay. Anyways, the degree is determined by the greatest exponent of the function, right? The greatest exponent that you can possibly find in that equation gives you the degree of the function. Then we have leading coefficients. Okay, the leading coefficient. The variable with it's the number in front of the variable with the greatest exponent is called leading coefficient. And it tells us the end behavior. It tells us the end behavior of a resulting graph. Okay, the LC tells you the end behavior of the resulting graph. That's very important. Then you have your constant. Okay, the constant, every polynomial function will have a constant. Okay, everyone will have a constant. The number without the variable attached to it. The constant will be the y value of the y-intercept of the function. That's important. Intercepts. The y-intercept is where the curve crosses the y-axis. Therefore, x is equal to 0. Okay, we state the y-intercept as follows. The y-intercept is always 0 and another number. That other number could be 0 as well. It could be 0, 0, which is your origin. The x-intercept is where the curve crosses the x-axis. And when that happens, y is equal to 0. So x-intercept is always a number followed by 0. The degree of the function, I already talked about that. And so we'll just dive right in here. So for example, this first one, this one would be a linear, right? Linear. The leading coefficient in this scenario is 2. Right? It's whatever's in front of the x. The constant is -5. So you go with sign and everything. The degree is 1. Because technically, if you go back here, x has an exponent of 1. Okay? That's why the degree is 1. The y-intercept, therefore, will be a coordinate. It's a point. It's 0 followed by -5. Okay, so that constant we had there gets inserted into the coordinate. Next, the leading coefficient in this scenario, it's an x squared here. That's the highest exponent for the x variable. So leading coefficient is -1/5. Constant is +25. It's just that number hovering by itself. The degree is 2 in this case. And the y-intercept is simply 0, 25. So get this, like you know for sure just by looking at it that this curve is going to go through this point. You're guaranteed that. Okay. Next, you have this long function here. The leading coefficient is negative 5.78. The constant is negative 75. The degree is 2, because, right, the highest power of x is squared. And then at 0, negative 75 is your y-intercept. This one over here, the highest power is x to the power of 3. So that is my leading coefficient. The constant is the number by itself, which is negative 50. The degree is 3. And my y-intercept would be 0, negative 50. There you have it. So it's just a little exploration activity. And if you'd like to highlight this, okay. So the constant is what I use for my y-intercept, okay? And now we're going to go to page 4 where we compare them all. Okay. So page 4. There's one that I haven't really seen I have never seen it on an exam. There's something that we call a constant function, which has a degree of 0. And it is simply, right, it is simply just a horizontal line, okay? So, and I think I will say at the very top here, next to constant, I will just say this looks like this. Y is equal to a number. That is what the equation of this will look like. So I won't do it for the other ones, but what would this one be? Y is equal to, just count. You go from the origin, you go up 1, 2, 3, 4, right? So y is equal to 4. That would be the equation of this line right there. This one, on the other hand, you're going down 4 units, so this is y is equal to negative 4. And so number of x-intercepts for this one is none. If y is equal to 0, like if you draw a line y is equal to 0, you have an infinite number of x-intercepts with this particular case, because it's going to be right on the x-axis. If y is equal to 0, has infinite x-intercepts, which is rare, but if it ever happens, that's what you should write down. Number of y-intercepts, it'll have 1. The end behavior, it either goes, so this is where end behavior, I touched on it last year, but it's been a while. It goes either from quadrant 2 to quadrant 1. Right? Or it will go from quadrant 3 to quadrant 4. So it's basically asking you, where are the ends? Where do they end up? The ends of the function, right? So the ends go from Q2 to Q1 or Q3 to Q4. It doesn't matter if you mix it up. If you were to say Q1 to 2 or 2 to 1, it doesn't matter. The order here doesn't matter. Okay. Your domain. Domain is all the permissible x values. So it would be 2 ways to state that. X, this is a weird way of doing it, I know that. X just belongs to all the real numbers, so anything goes. You're going from negative infinity to positive infinity. So that is your 2 ways of stating the domain and range. I'll do more on that later on. Your range is either y is equal to that number, okay? This is set notation. Or you simply say, you put square brackets and you just say that number. Again, this is a very weird, odd one. I don't spend a whole lot of time on this, but it does, when it does happen. Number of turning points. This is going to be important for the quadratic and the cubic. There are none, okay? There are no turning points with this one. It just keeps going the way it's been, the way it starts, it's the way it ends. Now, on to linear. Linear looks like this. Y is equal to ax plus b. Number of x-intercepts that this function will have. And I like to highlight the lines. Right? You can clearly see it's a straight line. Number of x-intercepts, 1. Number of y-intercepts, 1. It will always have 1. And behavior, it depends, okay? If the leading coefficient is positive, in other words, a is positive, you're going from Q3 to Q1. Your line is going to increase from left to right. So it's going to be Q3 to Q1. If the leading coefficient is negative, i.e. a is negative, you're going to be dropping. You're going to go from Q2 to Q4. Q2 to Q4. The domain is the same. All x values from negative infinity all the way to positive infinity are included here. So there's two ways of writing it. One is set notation, the other one is interval notation. Again, I'll do more of that later. Right now, just fill this in, okay? For the range, it's also all real numbers in this case. And it goes negative infinity to positive infinity as well. Turning points, none. It doesn't turn whatsoever. It just keeps going the way it started. If you wouldn't mind, I'm going to go on the graph itself and just say that this line, this has a positive, right? A leading coefficient that's positive. It's always going to go up from left to right. If it goes down like this from left to right, you have a negative leading coefficient. So if you want to distinguish that, you go for it, okay? Next is my quadratic up here. I'm going to go to quadratic. I'm going to make this work. Ax squared plus bx plus c. The only one that cannot be 0 is a, because if a is 0, it's no longer a quadratic. The degree is 2. And there you have your variations, right? That one, this one. Number of x-intercepts. This one could have, if you look up here, it could have 2 x-intercepts. Crosses it twice. It can have exactly 1, or it could have none. So this would be 0, 1, or 2. Number of y-intercepts, it always has 1 y-intercept. That's not up for debate. And behavior. If the leading coefficient is positive, in other words, if a is positive, let's go up to our graphs there. Both of these that are pointing up have a leading coefficient a that's positive. Okay? And therefore, this one that's pointing down, a is going to be a negative. You're expecting the leading coefficient to be negative if it's pointing down. If it's positive, it's going from Q2. Where is this one going to end up if you keep going? In quadrant 1. right? So it's always going to be Q2 to Q1, always. If the leading coefficient is negative, i.e. A is negative, it's going to go start at Q3, and it doesn't matter how big or small that graph is, eventually you end up in Q4. So this is Q3 to Q4. Domain is the same thing. All real numbers, right? It's just everything to the left on the of x, the x-axis to the left and to the right. So set notation is all real numbers. Interval notation is going from negative infinity to positive infinity. Just make sure you never have a square bracket around infinities, okay? The range, it's different. So for range, you have to be careful. If the leading coefficient is positive, you will have a certain range. If the leading coefficient is negative, you will have another range. So here it is. If it's positive, y is going to be greater than or equal to the y of the vertex. I'm going to go squiggly brackets like this. Let me zoom into that part, okay? Y is greater than or equal to the y value of the vertex. If the leading coefficient is negative, y is less than or equal to the y of the vertex. What in the world is the vertex, Mr. Dirksen? Do you remember what the vertex is? It's either the lowest point in the parabola, like the very lowest point, or the very highest point. So let's go and label that in our graphs real quick. I'm just going to label one of them. This would be the vertex right here. It's the turning point, actually. So vertex is like that highest or lowest point a curve ever reaches. So if you think about it, the range of this function, the only y values that are acceptable are like as low as the vertex goes in terms of the y values and anything above it. If it's facing down, it's the vertex, the y value of the vertex is the highest you can accept in terms of your y values, and everything below it, right? So that's why it's stated like this. I'm not going to do the interval notation. It's going to get too crowded there. Number of turning points, it has one turning point every single time. It turns at one point, right? It starts somewhere, it keeps going up, and then it turns right there and changes direction, okay? And now your cubic. You know what? I'm going to just, let's fill this in first. So the cubic is y is equal to ax cubed plus bx squared plus cx plus d. You can't see that, can you? There you go. It's this part right here. ax cubed plus bx squared plus cx plus d. So there's a lot more going on. However, a pattern that you're going to observe is that we only care really about the very first one and the constant. Those are the two that we really focus on. The rest, we're typing that into our calculator, and it's going to tell us the rest. Number of x-intercepts. This one can have 1, 2, or 3 x-intercepts. It is hard to see on the graph, okay? But this one right here, if you have a red pen, I wouldn't mind you actually highlighting this part. You remember the vertex, right? It's the lowest point. A cubic doesn't have the lowest point, but it has a low point right there, and then a high point right there, right? So it has two turning points. This one here has two turning points as well, right there and right there. This one has no turning point. This one at the end here. This one has no turning point. So can we go, I don't know why I skipped everything that I meant to fill in the rest, but let's go to the bottom of this number of turning points. It's either 0 or 2. There's nothing in between. It's either 0 or 2. Number of y-intercepts. This will always have one y-intercept. It will cross the y-axis at one point. End behavior. When it comes to the, when A is positive, let's go leading coefficient. Let's stick to the pattern here. If the leading coefficient is positive, A is positive, it goes from quadrant 3 to quadrant 1. If the leading coefficient is negative, i.e. A is negative, it does the opposite. It starts here and it ends in 4. So it goes from 2 to 4. And right now you just have to trust me. Domain is all real numbers. And the range is also all real numbers. This all changes once we do word problems, as you can probably remember from last year. And I'm going to use my iPad here to let you see the patterns here. Let's do the cubic first. Okay, so here's your cubic. I'm going to try to have it open for you to see that. So in terms of A, watch this. A is negative, right? As long as A stays negative, you're going to have the same thing happen than what a linear function does when A is negative. When the leading coefficient is negative, when we had our linear, it goes from quadrant 2 to quadrant 4, like that. Same thing with a cubic function. Okay, and I can actually play this, right? So A can either be positive or negative. When it's negative, it does the same as a linear. It goes down like this. If it's positive, it's actually going up like this. Okay, so that is what A can tell us. Which way is this pointing? Where are the ends going to be? Okay, so that is what A can highlight without even graphing. We should know if A is negative, we're expecting it to start in quadrant 2 and end up in quadrant 4 somewhere. What about the leading coefficient? The constant at the end. This is our y-intercept, right? Look at what it does to the graph. If you change the value of D, it shifts everything up or down, the whole thing. So for example, come on, pause. Right now, what is D here on the screen? It's negative 3.75, right? That's my constant. What's the y-intercept going to be? 0, negative 3.75, right? So look at what happens when I tap on it here. That is actually the y-intercept of this function. So if I wanted to increase this whole thing, shift it up, I just go and increase D and it shifts everything up. So now it's 8.4. If I tap on that y-intercept right there, it is now 0, 8.4. So the value of D just basically changes the height of this graph. It shifts it up and down like this. Now, what does B and C, what will they do to our graph? They twist it. They twist it every which way. That's what makes the turns. So let me play it. Let me see if I can get rid of this for now. Right? So it almost looks like a parabola at a certain time, right? But there it is. So it kind of shifts it. It creates those turns. I should probably stop and just make it slower, right? So for example, if I change B, it makes those two turns right here. There's a turn right there and a turn right there. Two turns. But there's a certain point where there's no turn. Okay, so that right there, I don't have a turn in that point. It's like a slide, right? It doesn't turn. So it's either 0 or 2. Okay, that's what a cubic does. Let's look at the quadratic just to, so you have that one. I need to open a new graph here. Parabolas. I'm going to turn everything off here. So you probably remember parabola, but A, the value of A, if it's positive, it's going to be pointing up. If I drag this pencil down to the negatives, it's going to be pointing down. Okay, so positive or negative, that's it. That's all I really want you to focus on. And what about the value of C? What happens if I change C? It does the same thing. It shifts everything up or down. Okay? But it also is always the y-intercept. So if I go tap on this graph right now, it's going to be 0, 5.4. So the C value tells me what the y-intercept is, and changing it, right? Changing it will either shift it up or shift it down, because you need to understand that part, that making changes to C or the constant will either lower the graph or raise it, okay? So that's that. And then let's not forget about our linear. Linear is right here. You can't see it very well, but down here is the AX plus B. Don't mind all of this mess here. Just look at this last one here. If I change A, right, if A is negative, this thing is pointing down. If A is positive, this thing is pointing up. Basically, that's what I want you to get from this. And if you change B in this case, B is the constant, guess what's going to happen? It either raises it or lowers it. It shifts it. But it is always my y-intercept. If I tap on it, the y-intercept is right there. Okay, it's 5.1. So those are some of the patterns. What if A is equal to 0? Let's make A equal to 0. That's going to be a constant function. Right there. So that's the first one we talked about. So if I change B, it's just basically going to make this horizontal line either be down here or up there. And remember, if B is equal to 2, it's going to go through 2, right? So the constant is always the y-intercept, no matter what. And the pattern here that I would like you to highlight in our booklet is this. There are similarities. Look at the end behavior between the linear, and then look at the end behavior between the cubic. What do you notice? If the leading coefficient is positive, they both go from Q3 to Q1. They behave the exact same way. If the leading coefficient is negative, Q2 to Q4. Okay, so I want to grab, if you have a color, I want to highlight those. Okay, so this one right here, this box right here jives with this box right there. They have the same end behavior. And then I'm going to grab a different color, and do you notice what that the constant function matches the quadratic in terms of the end behavior? That's one pattern I would like you to recognize. Let's go at the very bottom of this graph. What's the degree of this function? degree of a constant? It is 0. The degree of a linear is 1. The degree of a quadratic is 2. And then the degree of a cubic is 3. And here's the final say about this page that I'm going to say. A degree of 0 and 2 is even. They're both even. And a degree of 1 and 3, they're both odd, and they have the same end behavior. So that is one pattern that actually is true. We're not going to go past cubic, but if you did a quartic, which is a power of 4, or a quintic, which is a power of 5, that pattern would continue. That all of the odd polynomials with an odd degree, they share the same leading coefficient. And all the even degrees, what did I say, leading coefficient? They share the same end behavior, my bad. Right? If they're odd, they share the same end behavior. If they're even, they share the same end behavior. So I'm going to make a little statement there. Functions with even degrees share end behavior. Okay. Same with odds. Same with odd functions. So functions with even degrees share the same end behavior. And then we're going to skip to page 7. So I'm going to go on to 7. I'm going to start graphing a little bit. So one important button on your calculator, I'm just going to tell you right up front, okay? Especially if you're new to calculator world, or if you need a refresher from last year. When you start graphing, we're going to use the y equals, the window, the zoom, the trace, and the graph. Like these buttons are an absolute must. You need to know how to use them when we start graphing. Okay, we're kind of hovering around these buttons. And one of the really important buttons that you want to use is y equals. Y equals, I want you to actually press y equals and clear everything that's in there right now. Just clear it so that when we start graphing, nothing is bothering you. And can you please, I think some students do this on purpose to mess with you, okay? Go all the way down to y0. Make sure it's cleared, okay? Because some students put in an equation there and it throws everybody off, okay? So just make sure everything is cleared. The other thing I want you to make sure is you go to your plots. These 3 plots up there, just use your arrows to go up. Go all the way up. Make sure it's not highlighted. So let's say enter is what you press to deselect. So let's say for me, plot 1 is highlighted. We don't want that. So I'm going to go up, hit enter, and then when I go back down, it should not be selected. Okay, so that's another thing to make sure. Okay, got it? Next button we're going to press is window. The window sets the parameters of what your screen is showing you. And the only 4 I ever want you to mess with is xmin, xmax, ymin, ymax. Those are the only 4 I want you to change. It might be that if you get help from another teacher, they might say change the scale. I never change the scale because it doesn't affect you. Okay? So I just don't want you to have to worry about that. The next one, I want you to press zoom. There's a bunch of zooms, right? The ones that I'm going to use very, very frequently, make sure you pay attention to this, is zoom standard, Z standard, option number 6, and zoom stat. Don't use zoom stat until we get there. I'll talk to you about that one. But keep going down. Zoom fit is a lifesaver, especially in grade 12. Zoom fit is going to save you a lot of times. And just so you know, I use zoom standard first. If zoom standard is a fail, if it doesn't do a good job, then I go zoom fit. That is always the order in which I do things. Okay? Zoom standard, then zoom fit. Next, press trace. Actually, we're going to use trace, but we're always going to press what before we press trace? Do you remember? Second. Press second, then trace. We access the calculate function, and so these are some of the functions we're going to use to figure out certain points on the graph. Second trace. And then last but not least is going to be graph. Press graph. You should see something. If you get an error right now, it's zoom standard that saves you there. Zoom standard will fix your window problem, okay? So that's just an introduction or a review of this. So for the window, you need to make sure somewhere in one of these two here, remind yourself that X min changes this bar, X max changes what you see to the right, Y max changes what you see to the top, Y min changes what you see to the bottom. So if you need to have that on your study sheet, you do that, okay? So I call it chasing the curve. If you see a curve and you're like, wait a minute, I need to see way more, you need to chase it. You need to keep going until you start seeing the whole picture, okay? You want to see turns and x-intercepts. X-intercepts as well as y-intercepts. So every time, if you're wondering, is this good enough? Is this graph right here good enough? You want to see all the turns or the x-intercepts, y-intercepts. You want to see them all. I should say and. It's seeing all of it. Remember that, so I'm just reminding you of the 3 zooms that we're going to use. Note that from applied 30S that x-intercepts is the same thing as roots, is the same thing as zeros, is the same thing as solutions. So if I give you any one of them, that's what we're trying to do. We're finding the x-intercepts. There's also an axis of symmetry. Axis of symmetry, if you want to have a little quick sketch here, is the line that cuts it in half. This is the axis of symmetry. It's an imaginary line. It's an imaginary line. We don't actually graph it, but that we know it cuts our graph in half, especially if it's a parabola. So let's sketch the first one. Let's go over to page 8. For each of them, we will determine our intercepts, our local maximum and minimums, and then we're going to graph it. You want a scale, a consistent scale. You want labels. You want intercepts. You want any high and low points. Okay? So let's type this in. Before we type it in, what kind of function is this? Linear, quadratic, or cubic? It's linear, right? Linear. And the leading coefficient is what? Negative 2/3. Which way are we expecting this thing to go if it's negative? we're expecting this graph to go down like that. That's what we're expecting. What is my y-intercept? It's 0, comma 15. So see how much information I already know without even typing anything into my calculator, right? I found out a lot of things. So let's type in the equation into our calculator. Go y equals, you press y equals, type this in. If you're new to this world of the calculator, watch this. This I put in brackets. So I go bracket, use the negative button for the leading coefficient. Never use minus, because if you use minus, it's going to complain. It's going to give you a syntax error. So negative 2 divided by 3, that's what I type in, 2 divided by 3. This is your x button. Look up here next to alpha. That is our x variable button. Okay, so you got to press that, and then you go plus 15. So once the leading coefficient has been entered, if it's negative, use the negative button, not minus. After that, you can go minus, plus or minus, whatever is the case. You got this? Okay, let's graph it. Let's see what happens. Because we're newbies, well, some of you already know this stuff. Can we do zoom standard just once? Everybody, let's just zoom standard to see, all look at the same screen. So I press zoom, I go zoom standard or press 6. Oh, I just see a little bit up there, right? So what's the next zoom I'm going to use? Zoom, fit. So I go all the way down, or press 0, like that first number there tells you. If you press 0, you will access zoom fit. Let's try that one. That's much better. However, I see my y-intercept. I want to see the x-intercept a little clearer. So now I'm going to press window. And what do I have to change to see more to the bottom of this thing? Y-min, right? So I'm going to go window, Y-min, I'm going to go negative 20. Since Y-max is positive 21, I'm going to go negative 20. Don't use minus. You got to use negative for Y-min. And then hit graph. You can just start typing and it will overwrite whatever is in there. Hit graph. So now I see more to the negative Y values, but now I need to chase it. I need to increase the X max. So you go to window, X max, I'm going to make that, what should I do, 30? I'm going to do 30 for X max. It doesn't matter if you chose 50. That is a good graph. I see both intercepts. There's no turning point, so I don't have to worry about that. Okay? So my window, if you want my window settings, if you want to have this, I go to window, I go negative 10 to 30, right? Negative 10 to 30, and negative 20 to 21. That's just a reference. That's the window I selected. That works. I will never ask you to do that. You will not get marks for it. This is just for reference. Okay, let's find the x-intercept. And this is what I do to find the x-intercept. If you're new, you definitely want to write this down. And I actually require this to be written down next to your answer. We let y2 equal to 0. Then we go second, trace, intersect. Then this is just a note. Go close. Press enter 3 times. That's just a little note here for you. If you need to add this to your study sheet, you should do that. If you were in grade 11, you did this a lot, so you kind of know already what to do here. So let's go ahead and do that. I go press y equals. y2 is equal to 0. hit graph. I just would like to hit graph so that I can see that red line being drawn on the x-axis. Now I'm going to find the intersection between the line I graphed and the x-axis, basically. So we go second, trace, intersect, select intersect. And now my cursor is on the screen, but look up here, sometimes it's off the screen. So sometimes I'm just traveling out here a little bit. Sometimes you will not see it. Oh, it's following me? Never knew that. So you need to look at the coordinates. You don't go up or down arrow, just go left or right. I'm going to come to the left and make it appear. Okay? Once it appears, so will it shift to the right if I keep going past? Let's see. Oh. I did not know that. I've never done that before. Anyways, you want to get close to the intersection and then press enter 3 times. Enter, enter, enter. That is your x-intercept right there. So write that down as a coordinate. You do not need to label it on the graph as long as I see it somewhere outside that you figured that out. Y-intercept. Please write this down. You're going to go second, trace, value, and you're going to let x equal to 0. Then press enter. Mr. Harrison, don't we already know our y-intercept? Didn't you say it's 0, 15? Yes. But if you forget, this is the way out. So second, trace, value. So select that very first option. It will ask you for an x value. Down here you see it, right? You press 0 and then enter, and it says 0, 15. That's the coordinate right there. No surprises, but there it is. For a linear, that's all you need, guys. That's all you need to graph it. So let's go to our graph here, our grid that I provided. 22.5 is my x-intercept, somewhere over here, and 0, 15 is my y-intercept. You need to make them fit. So you need to pick a scale that works. Let's try this. 5, 10, 15, 20. It's a little tight. Like 22 is out here. So you either extend it, or I'm going to just go 10, 20, 30. I'm going to go with a consistent scale of 10. Make sure you do the same thing to the left. Negative 10, negative 20, that is good enough. Label your x-axis x, and your y-axis, put arrowheads, right? Arrowheads, and that's y. And you need to have a consistent scale on your x-axis, and you need to have a consistent scale on your y-axis. It doesn't have to be the same, but it has to be consistent. So let's see if I go up by 5. So will that work? 5, 10, 15, 20 works perfectly. Same going into the negatives. Negative 5, negative 10. Now I know you understand. You have a consistent scale. You don't have to label every single one. Let's plot these points. 22.5 goes right about, this will be 25 in between. 22.5 is right about there. And close enough is good enough. That's what we always joke about at the province when we mark. It actually is true. Close enough is good enough. So we're not going to split hair. It's like, wait a minute, should it be a bit more to the left or to the right? We're not going to do that. 0, 15, we know exactly where it is. So those ones would have to be exactly where it's supposed to be. Now you grab a ruler. And by the way, this should match your graph on the screen, please. Like if you're graphing going up like this and your screen is going down, you've got a problem, right? So you go this way. And because this is not a word problem, we extend it, go way past it, not a problem at all. And you almost have full marks at this point. You're missing one thing, your equation. I like to pick one of the ends and just add it there, and now you've got yourselves a full graph, full marks on that one. We didn't have turning points, so we didn't bother. Quadratics and cubics have turning points. Well, cubic not always, but if they do, you got to make sure you include them. So for those of you that need a refresher on how to use your calculator to find points, make sure you have these things entered on your calculator. Maybe you got to be a bit more specific even if you need more help getting there. Let's go to the next one, page 9. Don't worry about these numbers here, like this. Don't worry about that. It's supposed to be a domain from -200 to 800. Don't worry about that. Ignore it. Okay? Let's type this into our calculator. We go to y equals. Clear whatever is in there. Press clear. Start typing. -0.067. Hey, I made this years ago, guys. 6.7 wasn't even a thing. So I must have predicted the future or something. Don't forget the x variable. If you forget the x variable, it's not going to look at all to what it should. 197x plus 85. Look up here, check if you have the same. Before we graph, I want this exercise, I want this to really happen, okay? What do we know? The leading coefficient is negative, correct? This is a quadratic. Which way are we expecting our graph to open? If it's negative, we're expecting this to happen. Okay? And our y-intercept, we know our y-intercept, it is 0.85. Now let's graph it. It's probably going to be, a bad window, I can tell already, but let's see. Not bad. We got one of the legs, right? This is probably doing this, and it keeps going, and then it'll come down at some point somewhere over there. Let's do zoom standard. Zoom 6. I just press zoom 6. Oh, I still see one of the legs, and I know that it's doing this, right? Let's try zoom fit now. Zoom 0. Zoom 0 is the fastest way to do zoom fit. Still not it almost looks like a straight line, right? It's not a straight line. We know better, right? It's a quadratic. So let's chase the curve. What should we increase? X max and Y max. I'll do both at the same time. Window. Or let's do one at a time. You're still getting used to this. I'm gonna go 50 with X max. I don't know where this is gonna go. X max 50. Graph. Nope. Go window again. X max, I'm going to go 200 for X max. So what I'm trying to see is it coming back down, and it's still not coming back down. Let's try again. I'm getting impatient, so I'm going to go 1,000 now. Enough of joking around here, right? Oh, there it came down. Okay? It came back down. You got the window? You got it already? I'm pretending like I'm a dummy here, okay? So if you got your window, you do you, okay? Y max, what is the Y max? 1,000? I'm going to try 1,000 for Y max. Fail. I'm getting impatient now. I'm going to go 3,000. Still fail. What is it, guys? 10,000? 10,000? Yeah? Okay, I'm going to go 10,000. I was told by some reliable sources, 10,000 works. Okay? So, you know what I'm saying? It's a little frustrating. There's not a cookie cutter. It works every time. So you just have to kind of figure it out that way. Okay. How many x-intercepts do I have? 2. Let's find both of them. So x-intercept, I'm going to do that here. I'm going to go y2 is equal to 0. second trace intersect. What? What are you saying? Okay, let's, you have to do this twice. Twice in this case. So we got to go to y equals. I already kept it at 0. I didn't clear it, so it's already done. Hit graph. Let's find one or the other. Let's go second trace intersect. I'm closer to this one on the right side, so I'm just going to go closer to that one. Hit enter 3 times there. A bit closer, Mr. Dirksen? Sure. There we go. It doesn't matter. There's my intersection, 721.12. So 721.12, 0, and I have another one. We do this all over again. Second trace intersect. Now you're going to hover over to the left. So just keep going till you get closer to this point here. Hit enter 3 times. Enter, enter, enter. That one is negative 1.76. I could have made it 6.7, but I didn't think that far ahead. So that's my x-intercept. I've got that. What else do I need to find? The turning point. It's very important. We call that the vertex. So let's go vertex. Okay, this is where it gets a bit tricky. If the parabola points down, this is what we call a max. If the parabola points up, what do you think this is going to be called? It's going to be called a min. Okay? So to find the vertex, we press second trace either max or either min. So that's up to you what you're going to press. It has to be it's very case specific. I'm going to find that real quick. Second trace. This is max. So your vertex is here. Just look up here. It says left boundary. So if this is your vertex, it's saying, give me any point to the left of it. And I am on the left, correct? So press enter. Then it asks you, give me a right boundary. You're going to go over to the right. Anywhere to the right, that's good enough. Hit enter again. And when it says guess, we always hit enter. Then it will start looking for it. So there it is. 359.68. 8,752.73. I already know my y-intercept, correct? Okay. Okay, before the bell goes, I want to get this done. X-axis, y-axis, right? What scale do I need to use here? Look at that, one of mine is at 700. So I'm going to make this 500. I'm going to make this 1,000. So I'm basically, every single box for me is worth 100. What about in the y's? I go as high up as 8,700, right? That's like the highest y value I have here in terms of the vertex. So I'm going to go, let's see, 250, 500. No, sorry, never mind. 1, 2, 3, 4. I'm going to make this 5,000, and this is 10,000, which would make this 15,000. It's probably not the best scale, but it works. I'm going to go down to the negatives. Okay, your homework, guys. Pages 11 and 13. I will finish this real quick. I'm just going to plot. So 712 is right there. Negative 1.7 is right there. My vertex is at 359, 8,000 something. You just go like this. You go from the vertex and just kind of make it look symmetric. Last but not least is the function. You know why this happened, right? Because I talked about voluntary withdrawals in university.